Good day. Today we're going to be looking at compound probability. This is the probability of two or more events occurring. Now we have two types of compound probability. We have independent and dependent events. Independent, each event is its own probability. It does not affect one another. So given independent events A and B, the probability of both events occurring, the probability of A with B, is the product of the probability of A and the probability of B. So let's look at number 2. If the spinner only left is spun, then a letter from the word bingo is chosen at random. Find each probability. The probability of having a number at least 3. So at least 3 is including it. 3, 4, 5, 6, 7, 8, 9, and 10. So 8 out of the 10 possible outcomes. A vowel in bingo is I and O, 2 out of the 5 letters. Whenever I do this, I'm going to get 16 over 50. And we can say this is 8 over 25 or 32%. Try number 1. All right. A die is rolled twice, number 3. What is the probability of getting a number greater than 4 on both rolls? So that's 5 and 6 on per die. So there's 2 out of the 6 numbers that are greater than 4. I want this to happen twice. Four over 36. This is 1/9, so 11.1%. Okay. I want to do number 6 and 8. A month of the year and a day of the week are chosen at random. What is the probability of choosing a month starting with J? So that's January, June, and July. So 3 out of 12 months begin with J. A Wednesday. Wednesday occurs once out of our 7 days. That's 3 over 84. That's 1 over 28. Approximately 3.6%. Number 8. Vera guessed the last 3 questions on a multiple choice test. If each question had 4 answer choices, what is the probability that she got them all correct? First choice is 1/4 of a chance of getting it correct. Second question is 1/4. Third question is 1/4. I do want to make sure you know this could also be written 1/4 to the third power because we're doing it 3 times. Either way, this is 1 over 64. And I do not know what that is as a percentage. So let's look it up. About 1.2%. Sorry, 1.6%. Okay. Go ahead and pause it and try 4 through 7. I want to do number 10. Christian is guessing a 4-digit code to his parents' garage door opener. What is the probability that each digit is greater than 5? I recommend drawing this out. So like the numbers on your cell phone, We have 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. I want a number greater than 5, which is 6 through 9. That is 4 out of the 10 numbers. The reason why I tell you to draw the pad, I've noticed with students previously, they'll say this is 4 over 9, which is incorrect. All right, this is 4 digits. I'm going to raise this to the 4th power. This is 2/5, so 16 over 625. To 0.56%. Okay, try number 9. Dependent events. So the second type of compound probability is if the first chance occurring affects the second chance. So this is the probability of A times the probability of B after A. For questions 11 through 14, we're using this. A bag of marbles has 3 blue marbles, 10 green marbles, 4 yellow, and 8 red. When chosen at random and not replaced, I take it out and I throw it in the trash can. Find each probability. So what is the probability of first drawing a red marble? Where there are 8 red marbles out of 3 plus 10 is 13, plus 4 is 17, plus 8 is 25. So 8 out of 25 marbles are red. If I pull out that one red marble, I no longer have 25 in my bag. I have 24 marbles. Out of those 24, 3 are blue. This is 1 over 25, so 4%. What is the probability that both are yellow? If I have 4 yellow marbles at the beginning out of 25, I pull one out, so I no longer have 25 marbles, I have 24 marbles. Furthermore, because the marble I already pulled is yellow, I have 3 yellow remaining. This is 1 over 50, 2%. Try 12 and 13. After the completion of a race, 75 runners were asked if they ran a personal best time and if they trained for the race. Of those surveyed, 22 said they had a personal best, 46 said they trained for the race. Of those that said they had a personal best time, 18 had trained for the race. If 2 different runners in this group were chosen at random, find each probability. For these problems, I highly recommend you draw this out in a diagram. So in my runner diagram, I have 2 types of runners. I have personal best and trained. Of those surveyed, 22 had a personal best, 46 trained. Of those that had a personal best time, 18 had trained. So in the middle, I'm going to put my 18 people. For personal best, it is going to be 22 minus 18. To get 4 people had just a personal best. They did not train for it. 46 did train, but I'm going to subtract out the 18. 28 trained but did not have a personal best. Now the total amount of runners was 75, I think. 75. So the amount of people who did not train and did not run a best time. This is going to be 75 minus 4 minus 18 minus 28. 25 people neither trained nor ran a personal best time. Okay, now let's look at the problems. Both runners trained for the race, but did not run a personal best time. So the probability of people that finished in the race. They trained 28 out of my total 75. For the second group, that one is pulled out, so I have 27 over my 74 now. I don't know what this one is. %13.6%, approximately. Okay. So what is the probability? First, we choose a runner that had a personal best time. The people who had a personal best total is the 4 with just personal best plus the 18 in trained, so 22, out of my 75 people. The other runner neither trained nor had a personal best. This is my remainder number here that I found. So 25 over 74. %9.9%, approximately. Okay. Let's look at your answer key. This is all that I have for you today, and I hope you have a great rest of your day.